important. A bit around some of the sort of basics of HS1. And then this is kind of set out, we'll sort of work our way from St Pancras down the line. So through the London tunnels 1 and 2, what we refer to as section 1 and 2, which you'll no doubt learn about why. What's 300 km an hour or 108 miles an hour? I'm going to be metric all the way through because it is a metric railway. But 180 miles an hour, what's the track? What are the kind of challenges of that? How do you have junction work at 300 kilometers an hour? And kind of what the future holds for us and what we're looking to do. So this had to be explained to me as well, but I don't work for HS1. HS1 are owned by these two hedge funds, I guess. Don't ask me about that either. But in the HS1 HS1 have a 30-year concession to run the railway, which is now generally known as HS1, or probably most of you remember it being called CTRL, Channel Tunnel Rail Link. And then under that, you have got, there's lots of other stakeholders, but the three big ones are us. So we are Network Rail High Speed Limited. I'll talk about us in the section, but obviously we've got two major operators, one in Eurostar and one in Southeastern, so operating international and domestic services. So where do we fit in Network Rail? So I'm sure many of you are familiar with the regions. So we technically sit on the southern region, but we're kind of, so this is southern region with Kent, Sussex and Wessex, and this dashed line is us, because although we run through Kent, we are a completely separate company. And we are Network Rail High Speed, but we're a wholly owned subsidiary of Network Rail. Don't ask me any more complicated questions about how the financing or any of that works. So HS1, what are the basics? So 109 kilometres, that's Pancras International, down to the boundary with Eurotunnel, where Eurotunnel takes over, or GetLink as they're now called. So we don't go to Paris, so GetLink run the bit from this side to the other side, so if you get your car on the shuttle, that's their bit through the tunnel, and then on the other side it becomes SNCF and what's generally called Line 1, which is the northern line into Paris, and obviously services Brussels, which you probably saw more on the opening day of the Olympics. You probably learned more about the network, the high-speed network in France, as 3 of the lines were taken out. But yeah, 109 kilometres, I say it's all metric, 0 kp starts at Pancras, so then we talk down to 109 kilometres, 109.9, I think, technically. It says there, maximum speed, 300 kilometres an hour, 180 miles an hour. 4 stations on the line, 3 of them are NRHS managed, so we manage St Pancras, Stratford International and Ebbsfleet International. Ashford is not run by us. Again, don't ask me complicated questions. 2 operators, class 395, that's domestic, those are Southeastern trains, and class 373s, 374s, which are the Eurostars, the international trains. In terms of gauging, it's gauged to what's called UIC GC for freight at 140 kilometres an hour, and UIC GB1 for passenger at 300 kilometres an hour. 79 sets of NR60, R260s, whatever you want to call them, what you would probably see as a standard switch on Network Rail, and then 62 high-speed Fochlow swing nose crossings, which I'll talk about in a bit more. There are a lot of interfaces. I think certainly I was surprised how many, even at St Pancras, we interface with, I'm going to use the word NRIL because that's what we call the big Network Rail Infrastructure Limited. So we interface with them there. We interface again with them here on the North Kent lines, number of freight operators, and down here obviously we interface with Eurotunnel, GetLink. So what's the basics? Is permanent way. It's a nice glossy photo of some track. So talked a bit more detail in terms of the track, but 25 kilovolt overhead line. Everything that runs is an electric train other than some freight. There are currently, before someone asks, we are open for freight. There are currently no freight operations, but we are able to take them. They are obviously diesel. But yeah, 25 kilovolts, twin block, made by Stanton Bonner original sleepers. One of the great things that I was very excited about was, you'll notice there is not a tree in sight. So autumn doesn't really bother me, and having come from the Piccadilly line, that was a great joy. So yeah, engineered embankments, lots of the basics are basically very good. I mean, it's effectively built almost as an extension of the TGV network, which is why a lot of our signalling, a lot of our suppliers are European suppliers supplying into the European high-speed network. So it's basics. So yeah, Stanton Bonner twin block sleeper, which has nothing in the middle, but it does. It has a connecting bar in the middle, and ballast obviously fills in between. 60 E1 rail. It's often ground now to E2, but it's pretty much all original rail, so it's all E1. In the tunnels, it kind of uses the same sleeper, but in this kind of embedded booted sleeper design, but it's effectively the same design. Slab track is a Satiba 312V, which we'll talk about a bit more. And there's a Pandrel Viper in the St Pancras slab, but the main fastening system is what's called the Voshlo W14, which is kind of used on all the sleepers. So in terms of signalling, it operates with two different signalling systems. One which is generally referred to as KVB, which stands for, I won't try and do it in my best friend Jackson, but the reason it's KVB rather than CVB is so it doesn't get confused with control. So that's why it's referred to as KVB. But essentially, this is what you would know as fixed coloured signals with lights that go red and green and amber. Fixed aspects, sorry, I'm not a signalling engineer. So. With AWS or TPWS, mostly TPWS and ATP, it's all, and again, this was quite a shock to me, it's all within the low speed areas, basically. It's still got 6-hole IBJs, mostly, a couple of 4-holes. But to say that's within St Pancras, where the maximum speed is 80 kilometers an hour. Not that any train ever gets up to it, but we'll talk a bit more about that. And then once you get into the high-speed sections, it moves over to what's called TVM 430, transmission for one machine. So what you will see on the line is you now no longer have coloured aspects, because when TGV was being developed, they worked out that drivers can't really see coloured aspects at 300 kilometers an hour. So technically, the drivers, once they are at full line speed, they can pull the blind down, because all they have to do is follow the speed sign. I haven't met one who's done it yet, but that's technically what they're allowed to do, because I mean, one of the first things I did was work out what an emergency brake looked like at 300 kilometers an hour. And if you think it's a standard 1.2 meters per second, you can do the maths quickly, or it's about 5.5 kilometers for an emergency brake application. So you're not seeing anything. These are called the block markers. So they're about 1,500 meters long, 950 meters in the slightly slower speed section. But essentially, this is what the driver will see in the cab, telling them what speed to go, or will tell them in the next block you need to be ready to slow down. So effectively, you go from one block to the next one tells you to slow down, ready for the next one, and changes and flashes. Again, one of the great joys that I discovered on about my second day is the whole signalling system is completely bidirectional. We can turn the whole thing round, which is very useful in certain instances where you've basically got an up and a down, but we can run the whole thing backwards. Okay, so this is kind of geographically. So those of you who remember, my dad had lots of Eurotunnel shares, so we used to go and drive our car over France all the time. So we got to go for £1. He didn't make any money, but we got to go for £1. So Eurotunnel opened in 1990, and then Section 1 opened in 2003. So Section 1 takes you from the Eurotunnel boundary up to what we call the Forkham Junction, when Eurostar services ran into Waterloo. So before HS1 was built, and when all the press was, why can't our trains go as fast as they can in France? because you haven't built a high-speed railway yet. It's called Forkham Junction, and then Section 2, 2007, which essentially takes you from Ebbsfleet up to St Pancras through the through the Thames Tunnel and to the two big London tunnels, which we'll talk about. But in terms of overall kind of tonnages, quite nailed this. So that's kind of what it looks like. So if you think about everything comes into St Pancras through Stratford and gets to Ebbsfleet, and then at Ebbsfleet, half of the southeastern services will go off onto the North Kent lines, down through the Medway towns, through Kent, Deal, Market, through there. So we kind of lose about half of them. Half of them will go down to Ashford, and then some of those from Ashford will go basically round Kent and back on the North Kent line. But so really, when you think about it, and obviously all the Eurostars go from St Pancras all the way down. So in terms of tonnages, that first kind of section runs about 20 million gross tons, about 10 million gross tons, and this bit at the bottom is about 6 million gross tons. So not huge tonnage, or certainly for me, I was overjoyed. How loads of tonnages were. So it's a very boring slide, but just so you get an idea of some of the basics of a lot of standards were written effectively off an SNCF standard because they were already doing it. I think most of the lines started opening about the late 70s, early 80s, TGV network. So yeah, basic patrolling, kind of 10-week intervals with 12, 5 in some of the S&C. In terms of track recording, it runs every 6 weeks with tolerances on it. So effectively it's set up so if we miss one run, we can catch it up on the next one. So it's actually 12 weeks, but we do various different routes and things in between. Ultrasonics runs every 16 weeks. It's probably a bit overkill, but I have to work on that because we have very few defects at the moment. But yeah, in terms of, you know, when you came from a railway where you were sometimes doing 48-hour patrolling, it's quite a different beast. So let's start at the top. So St Pancras, so this is platform 6. This is the buffer stop. That's where our 0 kp mark is. So everything starts from there. It's a mixture of domestic and international platforms. Yeah, you can obviously see the original part station. There's obviously a lot of work to extend it out the back. What I really want to talk about, because this leads to a lot of issues, I kind of think about it as at least 2 different railways, if not 3 different railways. So you've seen there's kind of 3 different tonnages, but there's also 2 different signalling systems. And one of the biggest functions is effectively we run a south-east running railway, yet we have a north-facing terminus. So at some point, you have to get all the trains into a north-facing terminus. So some of these curves, these are about 400-metre radius curve around here, which for a high-speed train, which I'll talk about a little bit more, that's a pretty tight curve. So a lot of issues are aware, but essentially that is what we have to live with. The same talks about lots of interfaces here. So effectively, this King's Cross. This is where we cross the East Coast Main Line, normally referred to as the tin sheds, that goes over. But we also have connections with the East Coast Main Line, and I'm not going to talk about it too much, but you can actually get on the West Coast Main Line or to Euston just down here. So, you know, there were things that could have been done. As I say, so there's 400-metre radius curves kind of coming through here, and standard, most of the switches kind of C's and D's. So they're quite tight relatively for a train, which is a high-speed train, which we'll talk about a bit more. So this is kind of the junction work layout. As I say, you've only got an up and a down. This is where the tin sheds are with a big crossover. Have the relief road. So this is the relief road which comes around. These are domestic platforms, 11, 12, and 13, and then the international platforms. There are obviously other platforms here, which is the East Midlands services, but that is not our track. That is Network Rail's track, and in the subsurface station where the Thames links come through as well. So we don't manage any of that. This is all our track. It is very flexible. There are a lot of junctions, probably too many, but it does give you a lot of flexibility. And it also enables you to look at different things, because one of the beauties is no international trains ever run over this side. And then there is a connection here where they technically can, but they don't. So we'll talk about one of the issues which was identified, basically change of train. But yeah, phase being up and down, but there is a lot of junction work, lots of flexibility. So pancreas, so say Caesar D's, this is again for me like flange ways of 150 mil. I was like, oh, this is so easy. This is the tin sheds with the big crossover. So this is where there is a floating slab track on that. So it's ballasted track within that, onto a floating slab track, and then into slab track in the tunnels and ballast beyond that. As I say, we kind of suffer from a lot of issues in St Pancras because effectively the class 374, so the new Eurostar, has a very stiff suspension because it is a high-speed train, and to be dynamic, to be stable at those kind of speeds, you need a very stiff suspension. But when you try and get into St Pancras, it rips everything to pieces. The old 373, if you have seen them, if old 373 had a shared bogie in most of it, so it's actually quite soft for a high-speed train, relatively. And the 395, we'll talk about one particular issue, but 395 is kind of a compromise high-speed train because obviously it does operate on our line, but it also has to operate on the rail, and it's a bit of balance. But yeah, so we get lots of 053 failures, so we follow the same kind of standards in terms of switch inspections within St Pancras with RT60s. We actually had a failure on Tuesday night, fresh off the press. This was what I was doing last night because I'm the only one who can do the mini prof at the moment. Fortunately, it was in the sidings, so it was not an issue, but I couldn't really work out how we had a failure on a set of points where a train hasn't been over it for a year. So lots of issues. Those of you who are former colleagues will see that I was really delighted to find this stuff when I arrived. Vanguard in the platform doesn't seem to cause me any problems, fortunately. There's also some interesting alignments. I don't know whether it really shows on this photo, but there's some really interesting alignments around St Pancras, which are the design alignments because of trying to squeeze as much in as you could to give you that kind of flexibility. We spend more time probably at St Pancras in terms of maintenance than anywhere else because of all these kind of issues. But fortunately, again, it has a benefit of at least it's all in one place. So we can get there. And also for me, another great experience was you can just drive your car up onto the road and park right next to it. You don't have to abandon it in the middle of somewhere and wonder whether your car will be there when you go. I enjoyed that. So say lots of grinding, lots of 053 failures, where we wouldn't do inspections up there without grinders being available because we would be banning facing moves all over the place. Which, as I told people, is you can't get a high-speed train around those kind of coaches without causing wear. And on my first day, the ex-colleagues going to enjoy this story. They said, "Oh, I got some really bad corrugation at St Pancras," and I turned up and went, "Is that it?" But there are a few issues. There are a few spots up there, but again, nothing like what I'm used to. So when we come out of St Pancras, we hit London tunnels 1 and 2. So single bore concrete tunnels, as you say, go from the ballast onto this kind of booted sleeper effect. London Tunnel 1 is about 7 kilometres, and that brings you into Stratford, where you come out in the open air again into what we call the Stratford box, and then you get back into London Tunnel 2, which comes out pretty much by the Dartford crossing before you go into the Thames Tunnel. When you inspect long tunnels, we have motorised trolleys, or lumicarts as they're known. I was sceptical of what you see, but you actually see quite a lot. And fortunately, because it is not brand new, but it is relatively new, there are not that many failures. You are not looking at lots of missing clips, missing pads and that kind of stuff. And I'm amazed how much you do actually see. So yeah, that's just gives you a bit more of an idea. There's a walkway down each of the tunnels. So again, in terms of evacuation, you can get people out. There are head houses about every 3 kilometres, I think, through the tunnels for emergency evacuation. Yeah, so one of the first problems I arrived to was there were reports of trains hunting in London Tunnel 2, which I did a bit of digging, and some colleagues in technical authority sent me an article saying this has been an issue since the trains were first introduced. And as this article says, it was solved. That was October 2010. But we still seem to have issues with hunting in London tunnels here. And I said, well, with obviously my background, I was like, well, it will be a function of the equivalent canicity. So we need to measure some wheels and we need to measure some rails. So I went and measured the rail profiles in the tunnels, talked about how we identified it, and then I went and helped out wheel profiles as well. But what you all now have in your pocket is an accelerometer, a 3D accelerometer, 3-axis accelerometer. So I said, well, I will go, tell me the units that are getting reported, and I will go and sit in the train with my phone on the floor, which very helpful members of the public like to tell you your phone's on the floor. And we were able to pick up the units. So effectively, this is the graph, is time on the x-axis, and this is just the lateral acceleration. So the orange line is a train which does not hunt, and the blue one is one that does. Hopefully you can see the difference. It's quite violent, I'm not going to lie. And it lasts about a minute, but the reason I needed a train that didn't is so I can align the curvatures, because effectively off the traces I can say I know exactly where I am and then realign them. This is zoomed in just to show you, and when we worked it out, it's about 5 hertz, which is quite high if you read a lot of hunting studies. And at 210 kilometers an hour, which is what this train is doing, that equates to about an 11-meter wavelength. Quite high. But we had identified where it was at least. So when I took the rail profiles, normally, I'll try not to give you a whole wheel interface lecture, but it's normally a function of the wheel shape, the rail shape, and the gauge. Because effectively, if you tighten up the gauge for a very small lateral shift, you can set the train off hunting, right? So I said, okay, well, let's measure the gauge. I looked at the TRC, so we just use the normal rail TRC to run. And I looked at the data, and it showed a bit of tight gauge, but any of you who work with these trains will know that there's quite a variance between trains. So in 2024, it was telling me it was 3 mil tight, but in 2021, it was kind of about 2 mil tight. And my manual measurements, what you can hopefully see is they kind of follow a similar pattern, but they don't necessarily show the same absolute values. So I think there is a bit of tight gauge, but I suspect it has been there since construction, which I haven't been back through yet. And when we measured the wheels, and I said on my first day, I said, I will eat my hat if they haven't got hollow wheels. And this unit is about 50,000 miles, just about coming. This one is about 180,000. No, let's get my numbers right. 129,000. So it's about a mil and a half hollow. So there is some slightly tight gauge, but so, well, you might want to turn your wheels a bit more. Anyway, once I worked out that I now had this 3-axis accelerometer in my pocket, I started going on other trains. So that I don't have to talk all the time, I thought we'd play the game of which mode of transport is this. So I've given you the axis. So my phone is effectively aligned in this. So Y is pointing forwards, that is positive, X is lateral. So this is the, the wrong color. I was trying to get the colors. This is a lateral acceleration. And I've given you a speed profile of this mode of transport, just to try and help you out to see if you can work out what mode of transport this is. Given it's a railway that hunts.
Docklands.
Got marked on. So I often, we have an office in Stratford that I often get on a Lewisham, and there's quite a long straight, which I know is a common problem with DLR or straight hunting. And I recorded one train. This is again, I was rough calculation. I'm sure you all know this. I can see Tom's here, so he's going to tell me I'm wrong, but it's more like 1.5 hertz. But that wavelength comes out about 9 meters. Is that about right? Yeah. So again, because kind of example I use is with the class 395. It is kind of a compromised train. It is a high-speed train, but it's actually got a relatively soft bogie. So the DLR is the other end of the scale, where it's got an extremely soft bogie, very low speed. But in order to get around, those 40-meter turnouts at Poplar. So the 395 is the other end of the scale, but it's effectively the same issue. but at a certain speed, all trains can hunt and can be activated by equivalent kineticity. Right. This one is another one, but I couldn't quite plot them all the same axis, but look at the Y. I would say look at the Y acceleration if you want to try and work out. This is not a railway. Bus? No.
Motorbike.
No.
You cycling?
Only out of this is a plane taking off.
Yeah.
So I was going to Frankfurt for a wedding, and again the air stewardesses look at you very strangely when you put on the phone. Luckily, but yeah. So again, I went to a conference a couple of years all about ride comfort, and at the time in my role in LU, I sort of concluded I don't really care, and that's basically because there is so little you could do about it. Speeds are much lower. Yeah. I always had this argument with Malcolm DeBell, who many of you know, that we should change the braking rate depending on the time of day, depending on how cramped in people were, because when they're cramped in, they're not going anywhere if the longitudinal braking is very hard. But anyway, this is quite fun just to show you, you know, when you take off in a plane, this is out of London City, so it's quite a small plane, but you know, you're kind of getting 4 meters per second longitudinal acceleration. And this is the last one. So that's got the X and the Y, but again, I plotted the speed just to kind of give it is kilometers an hour. But hopefully you'll see it starts and stops a lot.
Central.
No, this is the bus from Eltham to my house. Just wanted to show again, you know, and this is the point Felix Schmidt made in this conference that, you know, in railways we're often told, you know, our ride comfort is so crucial. People are just like, get on a bus and it tries to throw you on the floor pretty much every 500 meters, you know. So when we're thinking about it relatively, anyway, that was a bit of fun once I discovered what I could do with my phone. So as we move down, so we get to Stratford International. Sorry, give it its proper name. So as I said, we kind of come out of London Tunnel 1 into what we call the Stratford box. This is where we first start to see high-speed S&C. I was trying to fit it all in, but effectively, again, you've got international and domestic platforms, but also coming out the middle is this cord which goes up to Temple Mills, which is where the Eurostar depot is. But I said this was taken, we often use the international lounges or the international departure lounges for events, because no one else does. So I was stood there going, oh, this is a great, if you're a PWI engineer, this equal split out the middle. Absolutely beautiful. And no one seemed interested. Anyway, I thought some people here would appreciate it. Yes. Okay, so then you get into London Tunnel 2, which talks about, say, exactly the same construction, but takes you out to Ebbsfleet. So again, Ebbsfleet International. So Ebbsfleet is where we start to divide. So this is kind of the main station, which takes you down to the coast. This is where you go on to what we call the high level platforms, platform 5 and 6, which take you off onto the North Kent lines and down to Ramsgate and Deal. So just beyond that is our infrastructure maintenance depot, a place called Singlewell, just outside Gravesend. It's the Gravesend East exit, if you can find it. Where we have got stabling yard, see a lot of spares, not all of our spares, they're dotted out down the line. This was a nice corporate shot. I didn't take this photo of this rainbow out this MPV, but it's a very good space again, going from depots which are very cramped and you can barely get all your stuff into having a lot of space. Our MPVs are actually operated by Balfour Beatty, so there's another shed just down here. So they are owned by HS1, those MPVs, and operated by Balfour Beatty, but effectively we're the only people who use them. So again, it's quite a boring one, but just to kind of show you, so there's Ebbsfleet and up onto the North Kent lines, so Singlewell, and this is Falcombe Junction, so this is where the old bit. So the reason the depot is there is because when Section 1 opened, that was where effectively the line started for NRHS before it went off, before you went through Swanley up into Waterloo onto Tom's Patch, which I imagine is slightly different. So we also have 2 freight loops. As I say, it is open for freight. There is currently no freight operations, but the idea was it would be useful freight. So we have 2 freight loops, one at Singlewell and one at Lenham. I'm sure you all understand what a loop does, just to get the freight out of the way so the high speed trains can go through. But again, they are quite useful in incidents when you can stick trains out the way. Okay, so now on to the really interesting bit. So this is kind of a plot of the range of curvatures on the high speed network by percentage and by density. You will see a little cluster of 400-meter radius curves. They are all within St Pancras. If you get out, there's a couple of 2,000, but that kind of 3,000-meter radius curve is kind of the minimum for. And you could do your, I'll let you do your Kant efficiency calculations, but for 300 kilometers an hour, that's kind of the minimum radius you can have, even with kind of 90 mil. One of the first issues I kind of identified was that there's actually quite a lot of spots avoiding ballast. So I went out, as you all do when you're new and you sit in the front of a cab. So quite a lot of issues with spots avoiding ballast, which I couldn't quite work out. My kind of first big question was, is this isolated places where you've got UTXs or changes of stiffness, or I kind of concluded it's actually quite random. And we'll talk about what I think is happening there. So in terms of the design, if you go by the design rules of high-speed railways, curvatures, yes, it's kind of within what you would expect, but the vertical is really quite high. It is really on the edge of the limits of what is acceptable for high-speed operations. And if you go on it, I can't sit in front of the cab, but it really is quite a roller coaster. And having lived in Kent and cycled around it, it is very up and down. So there are a lot of vertical geometry issues. Well, I think they relate to issues, but yeah, it's really right on the limits. So in terms of 300 kilometer an hour track quality, this is kind of a piece of work I did. I kept saying, well, where is all the historic track recording data? Because that will show you over time what is happening. And I finally found it, and I spent 4 days writing some code to pull out. So this is basically, as you can see, 2004 up to 2023. There's a bit of a gap, obviously, where I don't know where the data is, but we'll try and come back to it. But in terms of trying to work out overall track quality, this is actually for the 70-meter top. So again, in the kind of high speed, we talk about 35 and 70-meter wavelengths, because at those speeds, the wavelengths are completely different, even if frequencies are the same. But yeah, I've kind of concluded that overall our vertical track geometry has not necessarily been maintained as well as it could. Be very careful what I say. Not worried about it from a kind of safety point of view, but in terms of overall track quality, been quite a lot of. I think we have tamped sites where we think there's a problem rather than looking at the overall quality. But now we have all this data, we can kind of see. Obviously, this is kind of in 200-meter sections rather than eighths of a mile. But obviously, you can see some sections kind of a steady degradation. Other sections you can see where we obviously have had issues and we've tamped, so we've brought it back down again. But yeah, my kind of next big challenge is to create a longer term tamping strategy rather than a tactical campaign. This is out front of a cab. I don't know why I put this photo in, probably just because it's on the other side. So this is coming into the Channel Tunnel from the other side. And you can see the driver gets their speed in the front. But I would say the line 1 in France is a lot older, but it is quite a lot rougher. So say in terms of overall track quality, ballast condition is kind of the biggest concern. So this piece of kit that's been brought in, I don't know whether I think it has been used other places, but basically it's called a Pandoscope. And what you do is you dig into the ballast, you measure the response. But once you've dug this big spike in, you can stick a camera down, like an endoscope down it, and you can see where the ballast is clean and dirty. And this is kind of what we've used to look at our ballast cleaning campaign, which is kind of the first real big renewal that we're going to do in 2 or 3 years. So if we talk about junction work, again, this is quite boring, but this is our longest high-speed switches. So this is a Boschlo 1 in 46. So I've just put some numbers on there. That's 126 meters from the toes to the crossing, which we'll talk about swing nose crossing. Yeah, that's got 11 supplementary drives on it. at a minimum, tightest radius through the turnout of 3,500 meters. So again, when you're looking, I came down here to Aldgate to have a look off the end of the platform to see my favourite. So when you're talking about A's and B's, where point rails become spice rails, this is very much the other end of the scale. Yeah, range of 1 in 46 is the quickest, so that's 300 kilometres an hour on the through route, 160 kilometres an hour, 100 miles an hour on the turnout. Generally used in locations for crossovers. So again, I was, first thing, you're new in the role, you're like, what are the most catastrophic things that could happen? Probably have a derailment on a high-speed set of S&C, so let's get out there and have a look at those. And what I thankfully discovered is that they are absolutely beautifully undercut. So these are the switches, but you can see, yeah, there's clearly no contact on the switch tip. They're so beautifully undercut. I could sleep that night. But yeah, this is one we replace. This is on a flatbed. You can see you need 3 or 4 wagons to get one on because they're so long. So at the other end, obviously you can't really have a fixed nosed crossing at those speeds. You need a swing nose crossing. Again, fairly standardly used in France, across the whole of Europe. Obviously, the idea is effectively you create a plain piece of rail by moving the nose of the crossing. This one is in our yard. It was just because I could take a nice photo in the daylight. This is on timber. None of ours are on timber. They're all on concrete bearers. But in France, there are sites still on timber bearers. Fairly similar to a switch in terms of its operation. It causes some issues with detection because you have to make sure they are both detecting and they are both detecting in the correct position. But yeah, it's pretty well designed, as I say, and allow me to sleep at night. However, I was told that we had a particular issue with a set of what's called 2251s, which is number 2 on this diagram. So you can see it's where it's on an overbridge, but we're getting quite a lot of failures. The point machines were, when they opened them up, there's lots of damage to the point machines. See Chris is on, who used to work with me. So they put some remote condition monitoring on them, see what's happening. And first thing I did was show a power spectral density, so PSD graph of the frequency. It's coming out about 50 hertz. And I said, well, that is one of 2 things. It is either you have got corrugation or the whole thing is bouncing up and down. And I saw the video and went, well, I think I know it's number 2. So quite a lot of issues. There was also a lot of wear on this crossing. Again, it had been replaced by the time I arrived. One of the things I've been working out is how do you measure the wear on these? Because my mini puff, which you've seen in all the photos, you can't necessarily get all the way round these. However, what you do have is these series of ribs kind of down. And what I'm trying to work out is whether I can use those as a reference. This is a casting, obviously, but you would like to think they weren't too far off the original cast. So if you just look, this is the photos for the report, but hopefully if you look on this one, you can see how it's probably been overground over the years. And effectively the cant being measured through it was about 8 mil, given it should be a flat junction. So I think it's been totally overground over the years. Yeah, trying to work out how we can monitor swing nose crossings. Okay, so that's kind of Chrisville. So that's one of the kind of, we just sort of have strategic crossovers, as I say, because it's totally bi-directional. We just have a series of crossovers in various locations so we can work around issues if we need to. They don't serve any particular purpose, which again is quite an issue in terms of they don't really get run on the turnout. They only really get used on the through route. There's money even where. Then we go to Ashford and say we don't manage Ashford International. You kind of come off, this is kind of the HS1 loop, you actually come off, there's 2 cords that bring you off into the station. Again, mainly used by the domestics now at high speed services. Just kind of as I sort of mentioned some of the plants, we have 5 MPVs or 5 pairs of MPVs because they work in pairs, they're all signalled obviously with both KVM and TVM and KVB, so we use them for all kinds of things. We have a STRAM as well, which is mainly used for overhead line. It's got a crane on it and various bits and pieces, and then the Illumicarts, as I say, which we kind of do our basic patrolling on. As rail management, say, first thing I obviously wanted to look at was rail defects. and was pleasantly surprised. They are pretty low. Again, lots of reasons for that, but there's been a fairly intensive grinding over the years. We bring in 2 machines. This is Speedo, is it RR24? Because it's got 24 stones. This is the S&C grinder, which again, for me, having been used to arguing about 8 stone machines, slightly different, and with a 48 stone machine again. But yeah, kind of working on what is our overall grinding strategy. Rail defects pretty low, but we've got sites with RCF, nothing severe, nothing we're managing, but how do we manage it overall? So I stole this slide. I had to do, in about my second week, I had to present an R&D showcase. I was like, well, I haven't done any of the R&D, but okay, I'll give it a go. So I put this graph up in a room full of not all engineers. So I'm assuming you all know what this is, but it was a test for them. So I was kind of using it to say, right, well, where are we in the bathtub curve of failure in terms of our assets? Well, the one issue that we have is that, yes, there are slight differences in age of the assets, but effectively they were all built at the same time. So in most railways, you are in various states of this across your network, but we're potentially in the same place everywhere. There are some slight differences, but overall, it's not exactly massive. So we have just finished, I'll talk about it a little bit. We've just finished our control period 3. So we have control periods as similar as a big network rail, where we have to go to the RRR, tell them what we're going to do, but we're a year behind, basically to detach us from the same process. But yeah, so we are about to finish CP3. And I said, well, from what I've seen, Braga might have been there about 3 months at this point. I said, I reckon we're about here. You know, we've had random failures, have some issues, but nothing massive. But I think in CP4, we'll definitely be starting to go up this curve. You know, yeah, it's not a heavily tonnaged railway, but it's still 20 years old. So issues of ballast that we're starting to see, various things. And if we don't start doing something in CP5, we'll definitely be up here. So, and RHS is really set up as an operation and maintenance business. It's not a capital renewals business. And I said, well, you've got 5 years to turn it into one, because that's where we need to be. Well, yeah, probably less. But so again, kind of trying to do some work on what is our overall renewal strategy. As I say, we have got ballast cleaning planned in year 3, so we're about 3 years away. So we will be, we've just let a contract to do 30 kilometres of ballast cleaning. It was something I'd never heard of. There's no point in cleaning any ballast on the underground because you just dig it all out. But so we've done a bit of work. So as I say, ballast for me is the biggest single concern. But again, it's, well, if you're doing the ballast, should we be re-railing at the same time? We have some data on the rail, but pretty much, other than isolated sites where you might have 7 or 8 mil headwear, about 3 mils, the biggest I've seen in most locations. So not particularly worried about the rail. And again, rail you can change fairly easily, although at the moment we don't have a method of doing it in the tunnels. But we will. In terms of sleepers, we had a few sleepers taken out and just looked at, and they will probably be there longer than I will. They will last forever by the looks of it. So I just like this photo because it shows the nice photo of the Medway Viaduct. It's kind of our biggest superstructure. This for you, Paul. You know, it's but yeah, obviously we go under the Thames, we go over the Medway. It's quite a long bridge, and the big job we did at Christmas was it has what we refer to as long expansion joints. This being a bridge, it has to move and contract with the temperature. And this was kind of a great example, really. This renewal has been planned since 2021, but being an organisation which hasn't really done big renewals, every time you got saying, are we going, people would normally say no. And so this year we finally did it, but the rails are 2021 rails that have been sat in the yard. So yes, this was what I spent my Christmas Eve doing. Yeah, but we changed, so they come in 2 pairs, so there's 8 to change in total. So it wasn't a huge job, but again, in terms of turning it into a capital renewals organisation, it was a good job to demonstrate what we can achieve. So we also have, that's part of the funding, we have kind of separate research and development pot, which was like, yep, I can spend all that for you, no problem. This project was already in flight, so this was some lateral tractability testing that was done in Southampton in the National Infrastructure Lab. Because the theory was, well, with a twin block sleeper, in terms of your lateral tractability and your prevention of buckling, my theory was, well, it's got two edges, so surely it should be better than a standard sleeper. But until we had some evidence of that, I wasn't brave enough to change the whole standard. But this graph, if you've seen these before, is basically where once you have conditioned the ballast, put it down, you then start basically pushing it sideways and seeing when it slips. So if you go with the standard G44 sleeper without a USP, and compare it to a twin block at a 3 mil deflection, which is kind of the first point you normally get a reading, we're about 20% higher. They did test it with some USPs, don't have USPs fitted, but there's a whole suite of testing that's been done by Darren Sharp. So it's useful to compare, and there's a, if we had USPs, would we get much more? Yes, we would, but at the end of the day, am I going to go and retrofit USPs to the whole line? No, but in the future be useful. So we've just got this report, just going through and kind of working out for our sleepers, can we push all those kind of, prevention of buckling numbers if we got 20% greater lateral stability. I've also had various projects running on the two class 374s. We have the monorail kit fitted, which is actually accelerometers on in-service trains. Again, it was kind of an R&D project that no one really sort of thought about what are we actually doing with this, but it has shown some really interesting stuff, but we haven't kind of worked out how we use it. Am I prepared to push out RTRC runs on the basis that I now have on board? What are the differences? Does it measure some things better? Does it measure them worse? Are we interested in absolute values, or is the relative enough? What happens if those two units come out of service? All the kind of things that you've got to think about. Let's say we have just finished this. This was published on the 6th of January, so this is nothing that isn't in the public domain. The lower fee, they have asked HS1 to charge lower track access charge. Eurostar are very keen on that. They tell us our track access charges are 3 times what they are on the continent. I say that's nice. That's not really my bit. The idea is this railway pays for itself. That was the theory, not hugely subsidised. But anyway, we have had quite challenges to make some savings, which there are lots of opportunities. And one of them is in, so I say try again because this was an inspection module. So the idea of this was that you could fit it on the MPV, run it up and down. So it's already got locations for downward facing cameras. It's also, you could just see up here, this is a bulletproof glass up here. The idea was someone would stand in there and look at the OLE. Not an expert on OLE, but I can't imagine you can measure the heights and staggers by eye. But it's got stations. This is a UGMS system that's just been taken away because it's been sat in our yard for 10 years and no one knows whether it works. But we're kind of looking at this again to say, why are we still doing manual patrolling, things that we're moving. I have seen enough of this to be convinced. So this is the AVA system, which I'm sure lots of people have seen. You need the full. So we've had some cameras fitted in the front of passenger trains. Generally, when we've done cab riding, we've just taken a camera. They can take that data, align it all. And at least, when you've done the cab ride and at 300 kilometres, you go, oh, there's avoiding ballast there. I'm already 1.5 kilometres away, but you can come back through the video and align it. So it's been useful. This is the 2 class 153s, which Anglia have got, that are with all swinging, all dancing. So you can see under there, that's 7 cameras all facing down that give you this kind of view. And you can read the marking on the castings. I know Brian Whitney, if any of you have seen his recent stuff, is saying you can see squat type defects before they're ultrasonically detectable with it. Very interesting. So yeah, they've got 2 class 153s running around trying to move away from visual inspection. We have plenty of scope to do it because, again, we're in a point where there aren't lots of failures. There aren't lots of things to find. My only concern is if you really want to move it into the AI world of it finding stuff that's missing, how do you teach it if you haven't got enough stuff missing? do we start taking clips out in the loops and things and kind of send it through, which has been tried before. In terms of the S&C, again, this is just a P8 gauge. This is a high-speed P8 gauge, effectively, for our high-speed sets. It has an S1002 wheel on it rather than a P8. We don't actually run any P8s, we run P12s and S1002s. Have a totally different flange angle. Won't get into that. This is the Felix unit, which I'm sure many of you have seen. It's been rolled out in various places. This is the one that I'm about to buy one. This is basically the Aptus laser profile. Just been approved for Networrail. This is kind of a halfway. This is, for me, this is if you've got lots of densely located junction work where you can run it around for a couple of nights and do everything. When you've got crossovers in the middle of nowhere, this will probably do most of it, and you can just take it out and you don't have to have possessions and lots of people. Someone can go out and do it. But it's also better than someone with a calibrated fag paper doing an 053 when I have to go out the next night and mini profit anyway. So again, this is nothing that is in the press. There's a big push within HS1 to have a second international operator. So that's all in the press. We were given a number of scenarios. Obviously, COVID, like everything, hit HS1, the whole HS1 ecosystem pretty hard. And we were obviously, we were kind of in the middle of the control period. So we were already working on the next control period. It was very hard to say, well, what does future tonnages look like? So we were given a range of options to kind of work off. I think you can discount the bottom two. Eurostar are quoting they're pretty much pre-pandemic numbers. Need some more trains. They have ordered some, but as I say, HS1's big push is to get more international operators. One of the fundamental issues with that, which again is not something I had really thought about, is I'm involved, but if you go through St Pancras through the restricted zone, so once you're through passport control, which we don't control, that's all under Eurostar's control, is you go through passport control, but once you get through the other side, there ain't a lot of room. And you only need one train almost to be cancelled before people are queued all the way down what we call the arcade, which is where all the shops are, because there isn't enough room the other side. So if you want to run more trains, probably need to look at expanding that side. And one of the other things that I had never really thought about, having run an international railway, is once you've been through passport control, you are legally in France. Okay? So if you have an issue, like you have a dewirement, you can't detrain that train because you can't just let people off. You can't just put it in a platform somewhere because they would all have to go back through passport control and all go back through customs. Obviously, at the moment, we only have one international station, so they all have to be got back to St Pancras. Same is true if you think about it the other way around. If you had an incoming train, you could detrain it because they're all legally in the UK at that point. But again, just kind of fundamental things in operations which have to be thought about slightly differently when you've got an international train. So that's a bit of a whistle stop tour, but thank you very much.
Yeah, there's some questions online.
Okay.
It's interesting how you've gone from everything above 400 meters freight to
1,000 meters. So it's straight.
There's a couple of questions online. There's one about freight, but I think you've answered it because there's no freight running at the moment. The dozens NR60 switches, are they original design? If renewing them, do you replace them with Mark II ones?
So yes, they were originally of the Mark 1. They now go in as the Mark II, but essentially the footprint isn't too different. So one of the things I probably didn't talk about is that the whole P8 is based on 65 degrees of failure. Well, an S1002 and a P12 both have a 70-degree flange angle. So you immediately start with your switches at the wrong angle, which is something, again, I'm looking at is whether we would move away and have a bespoke design. But obviously, one of the issues with having a bespoke design is they're bespoke and the costs go up, and are we going to order enough? Whereas we can buy them off the shelf like everyone else in the country. So yeah, interesting question.
There's a couple of questions about transition zones. I think you've shown a photo, and someone asking what type of Stephens transition do you put there? Just a small photo.
Okay. Yes, there is. So about 5 years ago, I want to say, there was quite a lot of issues around some of the transitions. So a lot of them have relayed. So the transition has a USP effectively on it. There are some ballast, running the ballast down effectively on some of them. But I have not really looked at that in any more detail.
And there's something about aeronautics in the tunnels. What are the speeds?
Okay, yeah, probably I should say that. So yeah, we only get to 300 kilometers an hour basically once you get out of the tunnels. Maximum speed within the tunnels is 220. And the 395s are limited to 220 for the whole line anyway. Eurostar's the only ones that run 300.
Any questions in the room?
Just one thought on plants and pods and whatever. Have you had a word with Elizabeth Line?
I believe plant guys have. Yes, we are looking at lots of options now of what we can look at getting, because again,
Just that
the volumes were so low before it wasn't worth it. Now the volumes are going to be obviously in the realms where you.
Yeah, well, just thinking about the trains they have, the pods, that sort of thing, which are a modern railway sort of equipment, flexible, and not too difficult to get from them to you.
Anyone else? Otherwise, there's a couple of people.
Do you have any road rail access points now? Because remember pricing up or looking at some designs for access points at various places.
Yes, that's funny. Someone I was literally talking about that just before I left. So yes, we have quite a few. They're generally in the loops because lower speed, non-passenger movements generally. It is a big question. There are differing opinions within the business about whether you should be using RRVs on a high-speed network. I personally think you need the flexibility. All those expansion switches at Christmas, they were all done with RRVs. Yes, you could do it with a train, but you've got to get a train. Like getting rail onto the line is difficult enough without limiting all your other options. But there's a bit of a fear of them being on a high-speed line. There shouldn't be any rail stored in the tunnels, according to standards, but there is. And if someone said, well, I've done a 10-year trial for you because it's been there 10 years and it's not moved. It's kind of a fear again of anything at high speed, can it move? It's like, well, let's find out. But let's find out in a controlled way.
Question, Andy. You inferred in your presentation that you're moving from a kind of a maintenance to renewal type organisation, but you didn't say or state that you would. So is the inference that you'd use the same money to reduce or make maintenance efficient and use that for capital projects, or will there be an injection? Because that wasn't.
Yeah, well, I avoid complicated questions about money. I say how the contract is set up between us and HS1. It will be good if we do more renewals, because effectively we get paid for renewals. We don't get paid. We have a fixed price for the O&M. We get paid for renewals.
But that would come from them.
Yeah, I mean, a lot of that, again, the track action, the theory of it, and lots of people in the room probably know better than I do, the theory of the setup was, as I say, this railway will not be subsidised. So the operators will pay for the 40-year life cycle of the railway. So our contract says when it ends in 2037, we should hand back the railway in the same state we found it. Therefore, we should have enough money to renew everything we need to renew and hand it back. That's why your ticket between Zeb's fleet costs 25 quid. That's not for me to get involved with.
The 53 gauge there, we spoke to different wheel profiles.
So that one on the high speed is, so we use the standard 053, the P8 gauge with an NR on the NR60s. On the wash loads, we use this, which is effectively the same. That's an S1002 wheel, which is the Eurostar wheel. And again, because there should be no contact through, you shouldn't be looking for the same things. It's really about checking for tip strike. That's the biggest risk. But as I've said, they're so beautifully undercut. It would be very hard.
So on the wheel profile, if you get new operators.
Yep.
Is there going to be a thing about mandating the wheel profile for the trains?
Ask John.
You're going to be in the fun game of different.
I am not really allowed to talk about the new operators because I have a NDA.
What's the app you got on your iPhone?
It's called Sensor Play, and it is about 15 quid. So you have to be. Yes, if anybody wants to see it.
Company to pay for it.
But yeah, it's sure if you know Mark Burstow, and he first started showing me it, and I was like, oh, that's brilliant. I'm sure the academics will argue, but it won't be accurate enough. I was like, well, it's accurate enough for me to find a bit of the tunnel I need to do the rail profile on, because I'm not mini proffing 10 kilometres of tunnel. I can tell you that for free.
And entertaining as well.
And so I can narrow it down to, and I can do things like scare people on trains by putting my phone on aeroplanes.
Sean,
What led you go up to having a 126 metre switch, 11 sub-drives?
So that is so the letters we don't go beyond. We don't really use letter because they're a Voshlow design. So it's a 1 in 46. So effectively, that's the angle of the crossing nose. So that's the longest. They're then 1 in 21s. So 1 in 15, I think, is the shortest swing nose. But yes, I believe HS2 are developing, or really developing their whole own suite to tie into HS2. He said, "Do you want a 1 in 46?" But that does, and let's not beat around the bush. Before Brexit, I could order one, and it could be here in 2 weeks. And now it is not 2 weeks, and it costs a lot more money because we're effectively a European railway. Anyway, I won't say any more on that.
yeah, Southern used to get outro crossings from the line back in VR days.
Yeah.
Because it was an awful lot easier getting them from the line than getting them from Edgar Allen. Which is why you still see places on south of the river with the timbers close together under the crossing.
You didn't reference milling as just grinding, Andy, yeah?
They're just grinding at the moment. They're being moved towards milling. I'm looking at some of the machines, but I said, well, having been around this loop a few times, the cost of a miller versus cost of a grinder, you really have to have enough work for it. It's actually often, if you've only got isolated spots where your depths are 2 or 3 mil, it's probably cheaper to re-rail it. But yeah, I haven't kind of done that. I had to write a tamping strategy first.
Have you seen any problems that like cross discipline, like problems with civils affecting track or way?
Of course not. 200 years of silo mentality. Never seen that. No, I mean, the points was a classic example of signals of saying our point machines are getting shaken to pieces. And I don't think anyone in track was like, well, it's all standard. Like, well, that doesn't mean it's any good. You have to delve a bit deeper. And I think Chris is on the call. Chris and I were doing, last week I was doing now, he was doing lots of work on damage to point machines caused by corrugation in this case. But I was like, well, it's still a problem that we need to sort out. I can't necessarily say I can solve it overnight. But I think being in a smaller organisation obviously helps with that. You haven't got quite so many barriers and you're not quite so spread out geographically. But yeah, there's obviously still the same issues.
There's a couple of hands raised online. Midja, I think. Otherwise, David.
Yeah, hi Andy, thanks for that great presentation. You skirted over my question. I think it was about how you're going to manage the deficiencies if you're going to run lower speed trains on a high speed design network.
So you mean for freight operations?
Yeah, or passenger. I'm got the same problem at the moment that I'm looking at. So I'm hoping you're going to come up with a solution.
I'll say there are no freight operations. We already have 2 trains operating at different speeds. So obviously they're operating at different efficiencies. I I haven't really identified any areas where it's been a huge issue because, again, the number of trains, even when there was freight running, they were so low in proportion. It's not like having an ATO railway, I can tell you that. But yeah, I haven't seen any particular issues. Say in St Pancras, yes, there's places where there's low rail damage. I mean, we are tentatively looking at ERTMS, ETCS, and what that's going to have an effect, and that will have an element of ATO, which will probably mean the trains actually drive at the design speed within St Pancras, because at the moment they don't, and you know.
So you're not seeing anywhere on the low rails on lower speeds?
No, I haven't seen any huge issues. Most of the RCF is kind of classic high rail gauge corner stuff.
Okay.
Not a particular issue.
And because you mentioned hunting earlier on in and around the tunnels areas, I was just curious as to whether there was any issues with the aeronautics and the walkways in the London tunnels.
I think so. Certainly nothing I've been asked about.
Okay.
Yeah.
Cool. Thank you.
Thank you, David. Omar?
Hi, Andy. Lovely presentation. Really beautiful. Just a quick question. I've had experience with these swing nose crossings before, and we had some issues in when it got hot. How's your rail stress managed on high speed one? Is it the
Yes.
same or is that slightly different?
No, I mean we manage it at the same standard as I talked about, looking at whether we can increase some of our rate for some of our temperatures can go up. We have temperatures at which blanket speeds should go on, but it's managed it the same way. But yes, we have seen issues with swing nose crossings in the heat. I think they could be set up slightly differently. That would help. I think some of the tolerances are very tight. They fail on the FPL at 3 mil, which is tight when you look at them. But also, if one of them fails, then I'm out of a job. So it's so yeah. But yeah, I would say we are looking at it with like everyone in the industry. What should our stress-free temperature be? Should we be going up?
Yeah.
Reasonable argument for that, but you have one cold winter and everyone goes, "Ooh."
Is your adjustment switches different? Are they sort of
Yeah,
the structural types?
In the high-speed section, yes, they are longer basically. I mean, those long expansion joints on the Medway viaduct are effectively a very long scarf switch.
Scarf.
Yeah. But yes, within lower speed areas, they're standard scarf switches.
That's all for me. Thanks.
Thank you, Mark. Is there anything else? Any other question in the room?
So on that expansion, what's the movement you're talking about?
It's a very good question, Paul.
Sorry, structural engineering.
Didn't have a very hot summer last summer, so I didn't get. We had a new managing director. The first thing he said to me, he said, "Oh, that forecast says it's going to be the hottest summer ever." And I said, "Well, as an old chairman of a cricket club I used to play for, said you never cancel a game on a forecast."
Last a bit about a bit curious about the renewals in the future. Would you foresee some long blockades whatsoever?
Sorry, I see blockers to the future.
Blockades in the future for the renewals.
Well, I mean, I again sat with my sort of counterpart in HSS1 on about my second day and said, we will have to close this railway at some point because at the moment we have Christmas Day. That is the only day we have to do any work. And there are lots of things. When we get to doing full renewals, can you do as I say, it's bi-directional. So if you can find a method of doing a full renewal on one and keep the other line open, I think they'll be happy with that. But it's pretty risky when, it will be the first time anyone's done it.
Well, SNCF do it.
They do. And have you been on one of those sites? But that's the big one for me. And, I think the other thing I had, again, something I hadn't really appreciated is if I go to Southeastern and say, I need a 52-hour closure, they'll be like, yeah, Easter, Christmas, whatever. You say that to Eurostar, absolutely not. you say I want to do a weekend, this is Friday is their busiest day of the year. So you've got two operators with completely different business models. So finding a way of doing it or a closure strategy is going to be very, very tricky. And especially if we have another operator with more trains, more tonnages, more. So yeah, I think that will be the big one if we do get a new operator.
There are no more questions. I think Sean. Thanks, Andy.
Thank you very much, Andy. Very interesting presentation. We usually refer to change as yards and miles, but it's a meterage system. Yeah. Give a good rundown on the configuration of what you've got, the numbers of switches and high-speed crossings, and high-speed swing nose crossings, and a very interesting review of the interfaces and how the railway progressed into being what it is now, in terms of both tunnel sections and why the depot is where it is. And one of the things maybe you might want to consider for your renewal strategy is, does the depot have stable capacity for your renewal items and stuff, as well as an area for material storage? And that's sort of one of the things we're learning in the Elizabeth line was re-railing, but that's a conversation for another time. Yeah. Your thought-provoking really on lateral track stability. It's another approach, and I suppose it's something we all have to consider. It's obvious that climate change is occurring. How much we can move once away, can we go that way, or do we actually have to go wider range? Time will tell. I was interested in what you had to say about inspections and how you're developing them. It's a bit gutted to see what your equivalent of the RMV had been stripped out and basically binned. Something that is useful, very useful to have, and I'd imagine for a river like you would need it. Yeah? My experience of AI so far is if you can teach it what's right, it's very interesting what's revealed as wrong. Yeah, and we've learned a lot from that in testing we've done. Sometimes what's wrong, the human eye has missed it and walked by it for about 5 or 6 years. Yeah, so
we've got examples of that one.
Yeah. So actually, AI can be a better tool in some instances. You know, whether you go rely on it totally, another question maybe, but it certainly has benefits. So it was a very interesting presentation. Thank you very much. The time hour tradition. We're finding a round of applause, please. Yeah.
Thank you, Andy, coming here today. Some of us will be kind of going for a quick time just around the corner. So thank you all for joining the line. Thank you all for coming here today. The next section meeting is going to be in a month. You got all the dates on the web page, and any kind of seminars. You can also see all the events on the web page. Again, thank you very much, and have a good night.
Yeah, share that, Nick.
Think about what I'm actually.
Excellent, thank you.
You got brilliant. You're a good.
Oh yeah, that's very entertaining. That's good.
Wow.
Yeah, it's good.
Interesting at least. Yeah.
Yeah.
Swing noses. Are you serious? And I've got loads of things. Still there. So you've got two still there. It's not secondly for you. Are you saying that? Having a drink? The class ones have done. Yeah, they've done for 6 minutes.
Yeah, good man.
Yeah, thanks for coming.
Yeah, they want to ever be right.
We've got to get that out. To get that.
Basically, stick it on.
When you out on there?
They're strapped down. People would just take one of the keys out.
I'll be watching.
Exactly.
We've got protection. No one can report.
Okay, we'll go with that one. But yeah, we've had some rail.
Paul Graham was on it.
It's like, yeah, 'cause I think it's the way.
Go and see Adam tomorrow and say that. Oh,
Yeah, we don't need your fancy kit. Can we send it back? As we look. Stuff around our railway. I just
I'm surprised you got both.
doesn't do anything except
Oh,
I can see you guys.
All right, okay, all right, okay.
Nice to meet you.
Oh, right, okay.
Anyway, the whole, there was 400 gone out. 300 scanned, so what?
All right,
I think that's the fear
good
with the
bit.
rail.
Gets your name and what have you out there, doesn't it? You never know what.
We still
you
do
know,
that.
Yeah.
Anyway, that's it, Paul.
Yeah, so we kind of.
Yeah.
Cheers, cheers.
Section, we're actually hosting a seminar next.
Yeah, I'm not sure that would have been like anybody to say to you about it. So the issue.
Yeah, if you want to do.
You go wrong one, but it's
Opportunity.